now we're going to see some other reactions of glucose. We've already seen some reactions of glucose, namely with HI and CH3COCl, that is acetyl chloride. And now we're going to see it with some other reagents. Now, when we put glucose and we put HiO4 in it, now HiO4 is nothing but periodic acid, and it is a very good oxidizing agent. So let me first name the glucose, the carbons of glucose as 1, 2, 3, 4, 5, and 6. So we know that we have got 6 carbon in glucose, and what this HiO4 is going to do is it is going to cleave the first 5 carbons, that is 1, 2, 3, 4, and the fifth carbon are going to form HC double bond O, OH, that is an acid, and the CH2OH, which is over here, this is going to form an aldehyde, HC will bond OH. So we are getting an acid and an aldehyde, namely formic acid and formaldehyde. So now we can see that HiO4, which is a strong oxidizing agent, has oxidized the respective D-glucose into 5 moles of carboxylic acid and 1 mole of aldehyde. Now, moving on to another reaction that we can see. So, this D-glucose, when it reacts with NH2OH, that is, that when glucose reacts with hydroxylamine. So, this is nothing but hydroxylamine, and now this is going to react and give us an oxime. So, what is an oxime? If we see here, this C is will get now attached to, already has an H over here. This double bond is removed, double bond O is removed, and in place of this O we get an NOH from this hydroxylamine. So this rest of the molecule will look exactly the same. So we get our carbohydrate back with only a little change at the first carbon, and now the rest of it looks exactly the same, and we call this as oxime. So we are getting an oxime when glucose reacts with hydroxylamine. Now next we are going to react our D-glucose with HCN. What is HCN? HCN is nothing but hydrogen cyanide, and when glucose is reacting with hydrogen cyanide, what we are getting is that at the first carbon, the CH remains intact, but now this O will be accompanied by and this O. So we have this O, and now this bond clearly breaks, the double bond is breaking, and we're getting an OH. This H is from HCN, the H of HCN, and this CN of HCN is coming at this particular place. So we are getting this particular compound, and the rest of our glucose is looking exactly the same. So when our glucose is reacting with hydrogen cyanide, that is HCN, we are getting this particular compound, and this is known as cyanohydrin. So this is a type of cyanohydrin, and glucose on reaction with HCN, that is hydrogen cyanide, gives cyanohydrin. Now, these two reactions that we have just discussed, namely with NH2OH and HCN, what this tell us about glucose is they confirm the presence of C double bond O, that is this carbonyl group in our glucose. So these two reactions also are confirming the presence of carbonyl group on the glucose. Now next, because glucose is an aldehyde, we've already discussed. So we have an aldehyde group over here, this particular group. So because of this aldehyde, we said that glucose will show a positive test for tolerance, reagent, and Fehling solution. So when we react this glucose with tolerance reagent and Fehling solution, what we are getting is, because these two reagents are nothing but oxidizing agents, they'll oxidize our aldehydic group, and what we get is C double bond O, which was already present of an aldehyde, and now in place of hydrogen we have an O negative, and the rest of the glucose looks exactly the same. So now what we observed here, because of this Tollens reagent, that D-glucose gives positive test, and we get an oxidized product because of this. So oxidation is occurring because of them, Tollens reagent and Fehling solution. And we know that any carbohydrate which gives positive Tollens reagent test and Fehling solution test is categorized as reducing sugar. So this proves that the reaction of glucose with Tollens and Fehling solution proves that glucose in fact is a reducing sugar. So we can just say that D-glucose is in fact a reducing sugar because it gives a positive Tollens reagent and a Fehling solution test.